Hello everyone, welcome back to the next lecture. So last time what we looked into was that we looked at how energy uses are increasing. We also started to look into that, we have also looked at into earlier that how energy uses are linked to carbon dioxide emissions, and we have started looking into that what was energy, how they started, people started using more and more energy, how the energy transition has happened over last 2 centuries, where more and more fossil fuel is being used, and with that emissions have been increasing. Now, so before we started looking into what I promised you to look into, an entity called KANPUR-NPTEL, let me take you to one more aspect of how energy usage has increased, and which has been linked to another aspect is of human development. So let us look into it before we kind of move into KANPUR-NPTEL. So human development index, which has been a kind of one of the measures of that how human race overall has improved, or in turns have got better quality of life over last few decades or few centuries, is basically a summary of average key dimensional that in terms of long and healthy life. So life expectancy has gone up, uh, uh, education level has gone up, and overall people have more food to eat, the child mortality rate has gone down. Overall it is a better human life overall, which is indicated by this parameter called human development index. Is basically a three-dimensional kind of a thing, which looks into long and healthy life, knowledge, and decent standard of living as three matrices, and we are kind of trying to obtain a good balance between the two things. It is not a political index. It is not an index which talks about negative aspects of human life as such. What it simply talks about is that how does a human development index looks like, that in terms of the empowerment issue, in terms of inequality issues, in terms of poverty issues. It does not reflect those things. It simply talks about the positive aspects of human development life aspects as such. What it basically talks about is kind of covers is per capita income. It talks about life expectancy as birth, long and healthy life, decent standard of living, access to knowledge, schooling years, means years of schooling. So all these are kind of taken as a one part of human development index as per another definition. So if you look at that how human development index has changed over last few decades, and if you, it's kind of no surprise that United States is one of the leading countries in terms of human development index. I'm not saying that that is the best one. There are the other countries also which we have not showing, because we are kind of primarily showing here countries which are more carbon emitting countries. So if you look from that side, United States, since it started developing earlier, so it takes few years for countries to start their development process, start using the resources, and or so far that has been the story, and we will look into this deeper, that so far this has been the story that people started using resources. Once they start using resources, they started using energy more and more, and that has led to this human development more and more. So since United States started its journey much earlier, much ahead of other countries world as an average also, so you can see that its human development index has been higher and has kind of remained higher so far, because it has kind of reached situation where it has all the basic amenities of a good life, which needs to be there as per certain definitions, or at least as per this specific definition of human development index. If you look at China, which is a highest emitter as of now, their human development index has started rising very fast, and that has overtaken the world average in about 2010 2011, just because they started using more and more resources of late, and more and more money has flown into that system after they became a manufacturing house. Their economy has grown a lot. So while they are not the highest emitter right now, but as you can see that the consumption overall, the since human race is overall developed, so per capita income would have gone up, life expectancy would have gone up, living standards would have gone up, so their consumptions would have started to increase. And so you would not be surprised to see that this curve will started looking up more and more. Human development index will look more higher. India has also started its upward journey, though it has lagged China and lagged world also, because as you know that India was still coming out of this years of not being independent, and India has only started its economic journey in last kind of 30-40 years, and from that time onwards India has started this development path. But still, if you look at India from today's perspective also, you will see that it is still lower than the world average of Human Development Index, and which means, in other terms, though India is the third highest emitter as of today, and in absolute terms that is much lower compared to US and China, but India, as you can imagine, would have to catch up this development index path. And since India has to do that, so India would be consuming much more energy going forward. And we will show you that there has been indication this Human Development Index has been directly linked to energy uses. It has been directly linked to emissions. It has been a very, very direct correlation. Let's start looking into this more and more. So I talked about certain countries in the first slide. So if you now start looking into deeper into Human Development Index and carbon dioxide emission per capita, what you would see is very, very clearly that the countries which has higher emission, whose Human Development Index is higher, their per capita emissions are higher, and it's a very strong correlation. It's almost it's a non-linear kind of an extrapolation, which you can clearly see. And the countries that we talked in the previous slide, United States lies here, China lies here, India lies here. So the circle here shows the size of the population, and this thing has been averaged over per person level. But as you can clearly see that the more developed the human race in those specific geographies are, the more CO2 emission they do. So this is a very clear-cut correlation. So what you can see from the previous slides, that as India and China will catch up this game of Human Development Index, they will also have more per capita emissions coming up. And since the population of these countries is higher compared to the rest of the world, so net cumulative carbon dioxide emissions for these countries will be even more higher. So that is something which these countries will have to be very careful about, that they cannot simply follow the model of the past, which has been followed by a lot of other countries as to achieve this development path. And we will look into this more in just coming few slides. Another index which has been there is that if you look at Human Development Index and energy use per capita, again a correlation which can be seen, though it kind of saturates energy per capita, kind of saturates beyond a point of Human Development Index. So beyond a point, humans do not need more energy, but as you can see that up to a certain point, at least some energy per capita is needed for humans to have a decent Human Development Index. And there has been cases where Human Development Index has been high, and still the energy per capita has been low, while some of these countries have not done so well. So again, it will vary depending upon that how these specific countries have kind of optimize their energy uses per capita, and we will look into that how do we kind of measure this index and what is the importance of this index in our context. Also, another thing which we observe through data is that if you look at CO2 emissions and GDP, there is also a very strong correlation in this, that if you look at how the word GDP has increased over last 30-40 years, there is a very clear correlation with respect to CO2 emission, and it is just the consumption based CO2. This does not include the land use change emissions and those aspects. It's just the consumption based CO2. If you look at it, there is a very, very clear indicator which kind of correlates with the GDP and the CO2 emission. So what we are seeing definitely is that Human Development Index, be per capita basis, or what we are seeing is that energy uses also, and also the CO2 emissions and GDP, all of them are getting a very high correlation factor. So the model of the world so far has been, you consume more and you develop more. You consume more and you are richer. But at the same time, you do more emissions. So that is in a very, very clear model of the world which has kind of evolved so far. Another indicator of that is very clearly when we look into energy and urbanization, which is one of the other model which is of development. And if you look at the world, the primary energy consumption has kind of gone up continuously, and the urban population also. Curve on the left hand side is primary energy consumption, and the graph on the right hand side is urban population as a percentage of the total population. As that word total population percentage in terms of urban population has increased along with the primary energy consumption also. So again, a indicator that as people move from rural part of the world to urban part of the world, again the energy uses keep on increasing. So another thing that it again leads to more consumption and leads to more energy uses. very clear indicators. Further indicators of energy use and CO2 emission per capita, if we correlate these two things also, there also we see a very strong correlation that energy use and CO2 per capita is also are very correlated, and which is very obvious, which we have seen in earlier graphs also, that as our energy use has gone up, our CO2 emissions have gone up, because fossil fuels are the prime sources of energy which we have used so far. So, uh, can they be decoupled? Yes, they can be decoupled, but we have to see specifically that how this decoupling will work, how this decoupling can happen, is something we need to see. But so far the world model has been that you consume more energy and you emit more, because fossil fuel has been the prime source of energy for most of the geographies. And that's why it's very clear thing that as the energy use has gone up, CO2 emission per capita also has gone up. And if you look at CO2, so energy use per person, and which we have also talked before, that developing nation has been using less energy per capita, and developed nation has been using more energy per capita. And as we have seen that developed economies are already showing a behavior that the more you consume, more you develop, and which has been a very clear-cut correlation so far. And that is a worrisome factor if you look at very carefully. You look at half of the world today. Half of the world, specifically most of the Africa, a good part of Southeast Asia, and some parts of Southern America still consumes less energy. But they consume less energy, but at the same time, they are also underdeveloped. If you look at the underdeveloped countries' names also, most of the underdeveloped countries will come from these geographies only. So it is a very kind of a worrisome factor that as these countries will now start traveling this path of development, are these countries going to be the major consumer of energy going forward? So what will happen? So as the development start, as the human development index will go up, which in turn will mean more energy use as per the current model I am talking about, and which in turn will mean more CO2 emission. Is that the path that we are going to follow? And that is because half of the world is still underdeveloped. Like, so if you look at the human development index, still what we were talking about, we are talking about that about 70% of the world is reaching that a good human development index. So 30% of the world still has to touch that human development index equation. If that is the case, it means 30% of the world will start consuming more and more as in next few years with the current model. Let's look at some more data. If you look at energy use per person, again a very clear indication that energy use per person is higher where the development index has been higher, is higher where people have more money to spend. It is lower in the countries where the development has not been so much. But what is changing, if you look at, if from that, if you then start looking into the curve on the right hand side, if you then start looking at that, what is the change in prime energy consumption over last few years, there you will start seeing that some of the countries which has been consuming a lot of earlier, some of the countries here, some of the countries here, some of the countries here, which has been consuming a lot of energy earlier, are now not consuming so much. But if you look at the consumption path, look at India, look at some country here, look at even China from that pattern, look at Australia, look at South America, some of these portion, look at Mexico. What we can very clearly see is that energy use per person, annual change in energy consumption for these geographies are increasing drastically. So let's not talk about Australia so much, because that could be a kind of an outlier. But look at this part of the geography, and if you look at this part of the geography, look at India, look at most of the Africa, and if you go to previous slide, their energy use per person has been low so far. So energy use per person has been low so far, and if you look at the change of the energy use in recent years is high for these geographies. So this part of the globe also have started following the beaten path, where they have now started consuming more energy, and they are becoming more emitters because they have to travel that path of the development. So overall, that classical model of development, which has been directly linked to energy consumption, which has been directly linked to general consumption, which has been directly linked thus in turn with the CO2 emission, is the path which these geographies also have started to follow. And some of the major if you look at this from a sector perspective, some of the sectors which are primarily responsible, which I already talked about, I think I'll just skip this for now. Let me, if I need, I'll come to this later on in the course. But the narrative that I've been trying to create for last few slides is that there is a definition which has been given, which is called Human Development Index. With that definition of Human Development Index, what has been shown is that more you consume, the higher is the Human Development Index, and that has been the clear data driven kind of a narrative which has been created, and which also mean more energy which is consumed by people, and with more energy it is higher emission. So that's a very clear path which world has taken to reach from a low development index to high development index, and consume more, use more energy, and have higher emissions. That's the path kind of world has taken over last few centuries or last few decades. It's very clear indicator from this data. So now, if and what we are seeing as a worrisome factor, as just to repeat myself, is that the world which has not been developed so much so far has also started following this trend now. They have also started going into this trend where they have started consuming more energy, so that they can reach to a place where they can have better HDIs. That would mean in terms that this part of the world will become higher emitter in next few decades. And also what has been seen is that, just to kind of build up on use this graph before I move forward, is that energy use in industry has been high, transport has been high, buildings has been high. These are three major sectors where the energy use is high. And if you look at, these are very clear cut areas, which is again very clear uses in which people consume, people use. Because why do you need so much of industry? Because we need to produce more so that people can consume more, or that is needed as the part of Human Development Index. So a lot of steel needs to be produced so that bridges can be made, houses can be made, buildings can be made, offices can be made, more cement needs to be made, and other kind of goods needs to be made in industry, so that people can get decent living. Not only that, but they can also get more goods to consume also. Similarly, world started travel a lot, so transport has been a very high emitter. But again, look at the amount of energy which is used in buildings. Now, building is already the second highest emitter, just if you talk in terms of one specific sector. If you look at the broader sector, now, as we know that half of the world still has to be built, and we read it in a lot of areas that half of the world still has to be built. Like most of the Africa, major part of Southeast Asia has to have a much more decent living for its people. So that would mean that the energy use in buildings in those specific geographies will also go up with the current model itself. So what we are very clearly seeing as a path going forward is that this part of the globe, which has not been part of the Human Development Index, which has been low on Human Development Index so far, will move on this path of higher Human Development Index. What it would in turn would mean is that this part of the world will start consuming more energy and will start emitting more, and that's a very clear cut path that we are seeing going forward, which is worrisome. If we then start looking into that, we are trying to reach a situation where we want emissions to go down. If you want emissions to go down, and what we are seeing as indicators in last few years, that's a very interesting kind of a counterintuitive paradigm which is getting created with this whole thing. And we need to start looking into this development model very differently from this classical model of development what has been done so far. So this is a narrative which I wanted to create before I kind of move forward. And to look about decoupling this models so far, or to understand the decoupling of this model, let us look at into an equation which helps us to understand this in very simple terms. This is called KANPUR-NPTEL. So this is simply a tool which kind of disintegrates this whole emissions into four major kind of indicators. So suppose F is the global emission from human resource, then what we can divide this F is into population, and the second indicator is then growth into population. So this is basically GDP. G is GDP, GDP per population. That's a kind of richness index on how rich per person is. Then the next part of the equation is how much of energy is consumed to arrive at this growth. And as you can see from the previous slides, that this has also been going up. And the last one is how much of the carbon dioxide emission is emitted per generation of energy. So if you start crossing the point here, E will cut from E, G will cut from G, P will cut from P. So it effectively is F into F. But what it is showing is that basically what we can say in other words is that emissions are directly proportional to population. They are directly proportional to amount of money per person has, about in terms of how much of energy is used in generating per capita or per dollar or per amount of money which is then getting accumulated as a total national wealth, and how much of emissions are created in generating that amount of energy. And if you look at historically, for whatever data I have shown you, our population has been going up, our world is getting richer and richer. We have been not very conservative in our consumption theory, as I have shown that it has been very clear indicator that as the world has earned more, they have used more energy. So energy has been going up along with the growth curve also. So this indicator also has been going up, and as we have used more and more fossil fuel, it means our emissions per unit of energy generation also has been going up. So all the four indicators has actually been going up. Now if we understand this thing from that perspective, how does world need to do it differently? Now if you will start thinking deeper, you can then start making some sense of that what could be some path of achieving this net zero emissions if we have to achieve faster and still develop at the same time. Can we start decoupling these things? Everything has been so coupled so far in terms of consumption leading to higher emission, and higher emission then in terms of that consumption has led to development. So development to consumption to emission has been the story so far. Can we start disintegrating this story slightly? And that is what KANPUR-NPTEL help us to kind of identify and help us to create the focus at the right area. Where should we focus? Where should we start focusing if we still want to go into a path where we need to emit less but not stop our growth? Can we come up with a model like this? And if you start looking into this equation, maybe you can start forming some views already. Let me help you to help build up those views further. So effectively, in other words, CO2 emission is related to global population, global GDP per capita, energy intensity and carbon intensity. Basically, energy intensity is amount of energy per unit of GDP or per dollar, or so since dollar has been used as a universal kind of a currency thing, or per rupees from that perspective. Carbon intensity is amount of CO2 per unit of energy which is being consumed. So don't mix the last two terms. What I have seen a lot of students do is that they mix energy intensity and carbon intensity a lot. And I'll try to help you to understand that how these two things are different. For example, if you start using LED bulb instead of a normal bulb, that will not go into that, you're not falling into this bracket, but you are using this specific indicator. You are playing with this indicator where you are using less energy to get the same amount of light. Getting the same amount of light, it means you can do the same amount of work. It means you can earn the same amount of dollar or same amount of money of what you want to do. But now you're consuming less energy. So using LED bulb instead of a normal bulb would lead to less energy intensity, not direct reduction of carbon intensity. If you use solar panel, however, so you are generating same amount of kilowatt hour using and emitting less CO2. So a solar panel will fall here and LED lamp will fall here. I hope you are able to understand this distinction, and as I kind of go along, I'll try to disintegrate these two parameters a lot for you, because I've seen a lot of students in my class also making this mistake where they put things in the wrong bracket, and what goes in energy intensity and what goes in carbon intensity. I know that doesn't matter from a broader picture, that everything leads to impact on emissions, but from a understanding perspective, from putting the focus in the right place, we need to learn how to kind of disintegrate the two things further more and more. So now let us understand that what can be done to mitigate if we have now disintegrated our emission into four major things, which is population, per capita GDP, energy intensity and carbon intensity. Let us now try to understand that what can be done. Now, population, as you can understand, that controlling population growth is a very sensitive area, but it can be influenced by education, maybe through access to healthcare, where people are not scared to people are not scared about child mortality, and they are not giving birth to more kids, so that they don't know how many kids will survive. If we can just give them that access to better healthcare, there has been clear indicators in the world that countries which have better healthcare, with countries which have seen better kind of better inflow of education and money, the birth rate in those countries have slowed down. Half of the world have actually started to slow down. Actually, more than half of the world has already started to slow down. But still, part of the geographies which are still not financially that well, part of the geographies which still lack that world class healthcare and uh, uh, that basic amenities, there the birth rate or the population growth rate is higher. And that's I think the more world starts getting more and more facilities, this indicator will come down. But all the indicators which is showing is that world is not slowing down in terms of, or world is not kind of started to get less people any soon. I think world is expecting to reach its plateau population by 2050 or 2060, somewhere around that line. Per capita GDP, again, this would mean reducing consumption. Basically, we have to go into a path that people need to consume less per capita, such as reducing use of new clothes, meat consumption, or shifting to less resource intensive products. That's a very clear behavioral intervention which needs to be brought in. Uh, can people start thinking in terms of that I don't need to consume so much to be happy? Like, can they start delinking the happiness index with the consumption index? So consumption has been directly kind of a linked to some kind of a happiness, or as soon as people have resources, they start consuming more. Can some kind of a education system can be brought in where people can start delinking the consumption with happiness? And if that happens, this indicator can get impacted. Sustainable lifestyles has to be promoted, shifting to more circular economies, shifting to more durable and repairable goods. Some movement on this has started, but having said that, it's also a very tricky one, because that would mean that economy might slow down. So that could also mean that there could be chances where the countries may not be earning so much, because suddenly the consumption may slow down. And if consumption slows down, that would companies will have money to put into renewable energy or new technologies or whatever needs to be done from a technical perspective, and have that money and enough money to to put into those technologies. So this is slightly tricky one, but if something can be done on this line, this has to be primarily done through behavioral intervention, a lot of education in terms of behavioral changes, a lot of education with respect to helping people understand that consuming less can also be a way to live, is the way probably this specific thing can be influenced. Next one is energy intensity. So that will primarily come from improving energy efficiency, implementing energy efficiency technologies, such as I will talk to you about one example, which was introducing LED bulbs instead of incandescent lamp. Can our buildings be made more efficient? Like, can our buildings be made in a way that they consume less air condition per area for cooling or for heating or for any other lighting uses or anything from that side? Can our transportation be more energy efficient? So working primarily on the technology side, where we need to make our devices make much more efficient, and we'll spend a lot of time on this specific indicator in next few lectures. Uh, this is primarily a technology driven thing, which is, and also a bit of thing where we will have to use with respect to the users pattern. So we will look deeper into this. The next one is the carbon intensity or the emission per unit of energy. This is where we have to make this definitive shift from fossil fuel based energy sources to non-fossil fuel based energy sources, and we have to move to resources like solar, wind, hydroelectric, improving the energy mix, like uses more natural gas wherever we cannot have this renewable energy sources. Can we use more natural gas instead of coal? And maybe at another day we may also have to include some kind of a uh, carbon sequestering method also here, to capture the carbon dioxide before it is released to environment, even after it has been used as part of the energy generation mechanism. So we will look into these technologies separately, but for now I'll spend more time on Kaya entity, understand this slightly better, because this takes some time to understand this specific aspect deeper before I start moving into specific data. So in this course, what we'll primarily focus is on what is happening on energy intensity or the efficiency side, what is happening primarily on the carbon intensity or emission per unit of energy, what is happening on these two things, and how these two indicators are being now used as major verticals to handle the lower emissions going forward. And we'll spend more time on this in coming lectures. Thank you.